a rainbow of heartfelt wishes to start your day. May I now request our organizing chairs to escort the dignitaries to the dais. A hearty welcome to all of you gathered here for the inaugural program of the second Global Conference on recent developments in computer and communication technologies and recent advancement in sustainable materials. Today, we are indeed fortunate enough to have this event graced by our chief guest, Dr. Mani VN, guest of honor, Dr. Tangaprakash S., our beloved principal, Dr. Shantaram Raisi, organizing chairs, Dr. Sangeeta DM and Dr. Kiran Kumar VG. A warm welcome to all of you here. Prayer is the key of the morning and bolt of the evening. God, our Creator, has stored within our minds and personalities great potential strength and abilities. Prayer helps us tap and develop these powers. With this, may I call upon Tanishka and team to invoke the blessings of Almighty with a prayer.
महाकाय कोटि सूर्य समप्रभा निर्विघ्नं कुरु मे देवा सर्वकार्येषु सर्वदा मोदलೊಂದಿಪೆ ನಿನಗೆ ಗಣನಾಥ ಆ ದೇವ ವಂದಿಪೆ ನಿನಗೆ ಗಣನಾಥ ಮೊದಲೊಂದಿಪೆ ನಿನಗೆ ಗಣನಾಥ ಆ ದೇವ ವಂದಿಪೆ ನಿನಗೆ ಗಣನಾಥ ಬಂದ ವಿಘ್ನಗಳ ಕಲೆ ಗಣನಾಥ ಬಂದ ವಿಘ್ನಗಳ ಕಲೆ ಗಣನಾಥ ಬಂದ ವಿಘ್ನ ಕಲೆ ಗಣನಾಥ ಆ ದೇವ ವಂದಿಪೆ ನಿನಗೆ ಮೊದಲೊಂದಿಪೆ ನಿನಗೆ ಗಣನಾಥ ಆ ದೇವ ವಂದಿಪೆ ನಿನಗೆ
Thank you. May I now request our organizing chair, Dr. Sangeeta DM, to do the honor of welcoming the dignitaries and also give insights about our college to the gathering.
A very good morning to all. It's my great pleasure, and on behalf of AG Institute of Engineering and Technology, Mangalore, to welcome all the researchers from abroad and within India to participate in the second global conference on recent developments in computer and communication technologies, GCRDCT 2022, and recent advancements in sustainable materials, GCRASM 2022. I'd like to brief about our college before proceeding for the inaugural program. AJ Institute of Engineering and Technology is the new venture of Lakshmi Memorial Education Trust, LMET, of 3 decades old, started by our beloved president, Dr. AJ Shetty, in the memory of his mother, late Lakshmi Shetty. AJIT started in the year 2016 with a vision of producing quality engineers by giving the all-round training program supported by sports, cultural, technical, etc. The outcome of that is that AJIT has become the leading engineering institutions in the Karnataka and identified as the extension center of VTU for the Mangalore region. The institution is having separate innovation club, startup club, consultation cell, and different student clubs such as automation club, eco club, aero club, radio club, IoT club, etc. To overall development of the students, our institution is having MOU with Microsoft, GTTC, KGTTI, Diligentix Solutions, etc. During the last year, institution has bagged the title as one of the best colleges in the survey of Knowledge View magazine. Also, our institution is felicitated as one among 150 colleges by AACP. Today, we are inaugurating the second global conference, GCRASM and GCRDC 2020. On this occasion, I am very much delighted to take the opportunity to welcome today's chief guest for the day, Dr. Mani VN, scientist, CMAT. On this occasion, on behalf of management, principal, staff, and student, we welcome you. We also have our organizing partner and guest of honor for the day, Dr. Tangaprakash S., Director, Diligentix Solutions, Coimbatore. Warm welcome to you, sir. We have the source of inspiration for the day, our principal, Dr. Shantaram Raisi. Welcome, sir. We have the organizing chair for the day, GCRDCT, Dr. Kiran Kumar, sir. Welcome you, sir. We also have with us today's researchers from different destinations. On behalf of whole AJIT family, we welcome you all. We have with us various heads of the department, teaching and non-teaching staff members. Welcome you all. We also have judges, participants, and invitees. Warm welcome to you all on behalf of AJIT family. It's my pleasure to welcome media and press members who has gathered here. Welcome for the press. Thank you all.
Thank you, ma'am. May I now request Dr. Anthony PJ, HOD of Department of Computer Science and Engineering, to florally welcome our chief guest, Dr. Mani VN. Thank you, sir. May I now request Dr. Rajesh Ray, Head of the Department, Mechanical Engineering, to welcome our guest of honor with the bouquet. Thank you, sir. May I request Dr. Vignesh, Associate Professor, Department of Mechanical Engineering, to florally welcome our principal, Dr. Shantaram Raisi, sir. Thank you, sir. May I request Dr. Lashmi, Associate Professor, Department of Computer Science and Engineering, to welcome our organizing chair GCRASM 2022, Dr. Sangeeta DM, with the bouquet. Thank you, ma'am. May I request Mr. John Vegas, Associate Professor, Department of Information Science and Engineering, to florally welcome Organizing Chair, GCRDCT 2022, Dr. Kiran Kumar VG, with the bouquet. Thank you, sir. Om Asato Ma Sadgamaya, Tamaso Ma Jyotirgamaya, Mrityor Ma Amritangamaya, Om Shanti, Shanti, Shanti. Light is a pretty universal symbol of truth, knowledge, and understanding. It acts as a guide, keeping us away from stumbling in the dark. I request the dignitaries on the dais to come forward for our auspicious tradition of lighting of lamp. Thank you. We have with us here today eminent personalities as our chief guest, Dr. Mani VN, and guest of honor, Dr. Tanga Prakash S. May I call upon Dr. Kiran Kumar VG, organizing chair, to introduce them to the gathering. Over to you, sir.
Take your own time for introduction, but complete it in 5 minutes.
Yes, sure. Respected dignitaries on and off the dais, faculty, non-teaching staff, participants for GC-RDCT 2022 and GC-RASM 2022, and the students of AJIET. Good morning to you all. I feel extremely honored to introduce the chief guest, Dr. V.N. Mani, Principal Scientist F at the Center for Materials of Electronics Technology, CMET, Department of Information Technology, Government of India, Hyderabad. He has an immense experience over 30 years and an expertise in the areas of electronic and energy materials. Dr. Mani sir has completed his MSc in Physical Electronics from Presidency College, University of Madras in the year 1985, PhD from Anna University in Semiconductor Modeling. Sir has carried out his postdoctoral research works at LCM and MCI France, NRC Taiwan in gallium arsenide and zinc oxide epitaxial semiconductor devices. Sir is also receiver of Young Scientist Award, Commonwealth Research Fellowship, Postdoctoral Fellowship, National Science Council Taiwan, Overseas Research Fellowships, CNRC France, UGC CSIR Junior Senior Research Fellowship. He has over 57 publications in international journals and 3 review reports to his credits. He has delivered over 41 motivational lectures in Government of India, DST, Inspire camps. He has been reviewer to TN government for 11th and 12th classes physics book for the year 2018-19. So that is Dr. V.N. Mani sir for you. The list goes on. I have shortened. So the guest of honor, Dr. Tanga Prakash S., Director, Diligent Solutions, Coimbatore, received his BE in Electrical Engineering from Bharatiyar University in 2002, ME in Power Electronics and Devices from Anna University, Chennai in 2014, PhD from Anna University in Electrical Engineering. He has worked in various colleges at engineering colleges at various capacities. 2011 to 2013, sir worked at School of Electrical Systems Engineering, University of Malaysia, Perlis, Malaysia. He has authored over 30 papers in international journals and conferences. He is editorial member for International Journal of Engineering, Science and Technology, Nigeria, senior member for IEEE, IEEE Power Electronics Society, IEEE Communication Society, organizing chair for various IEEE Springer Elsevier conferences, currently Vice Chair ECIM of IEEE India Council for the year 2021-22. We are indeed grateful to have these eminent personalities. Thank you, sir, for accepting our invitation and making your gracious presence. On behalf of AJIT family, I welcome you all, sir. Thank you.
Thank you, sir, for that beautiful introduction. May I now request our guest of honor, Dr. Tanga Prakash S., to brief us about the conference.
Respected chief guest of the second global conferences on RDCT and RASM, Dr. V.N. Mani sir, respected principal sir, and my dear organizers, Sangeeta ma'am and Kiran sir, Nagesh sir, and all the HODs and faculty members of AJIET, and my dear student friends. A very good morning to all of you and also the participants who joined offline as well as online. A very good morning to all of you. And I would like to take this opportunity as a privilege to share some progress about the conference, pre-conference and also post-conference activities. As far as RASM is concerned, we have received around 700 papers, and out of which 225 papers have been registered for RASM. In fact, we had limit with 225 papers. So 225 papers had been registered, and they are going to be presented by authors from various countries as well as different parts of India in these 2 days, today and tomorrow.
Different sessions.
Yes, with different parallel sessions. And as far as RDCT is concerned, we have around 80 registrations. Those papers also will be going to be presented parallelly in these 2 days. We have around 20 plus technical sessions, which will be coordinated by internal session coordinators from AJET and internal session technical chairs from AJET, and also external technical session chairs from different parts of India. So, and these 2 days, the timing and everything, the guidelines, everything we have shared with participants through WhatsApp group as well as through email, and also we have displayed in the website. So I request the participant to strictly adhere with the guidelines and also the timing, whatever presented to you. You need not to be there, you need not to join earlier in the session, or you need not to be there in all the, throughout the session, the full day, but you have to join at least 15-20 minutes before your timed schedule, and you have to be there. You have to present your paper in a timely manner so that the sessions will all go as per our schedule and timing. So that is very important part, because because we have given a timely basis, like 10:20 one paper, 10:30 one paper, like that. So everybody will look for presenting their own time. So this is the only thing which I request from the participants. And as far as the post-conference activities are concerned, we have conference kits to all the participants along with the print certificates. Those will be sent by post. So maybe we will start sending by next week. Once the conference get over, from next week we will start sending by post the certificate and all those things. So you will receive, and before that we will ask you the details like your current postal address, where it has to be sent, all those things. So it will be coordinated perfectly. Don't worry about that. And importantly, the publication process. So now, as I said, we have received around 700 papers, and out of which 225 papers have been registered. And we had made sure the quality of the papers. So all the papers which have been accepted are of very good quality, and there is no chance of removing them from materials day proceedings. However, it needs your support also, and also your punctuality also. Materials day proceedings, they have changed their policies nowadays recently. In the last 6 months, they have changed their policies drastically from their previous publishing process. Now, every conference proceedings, submission in materials day proceedings will open only after the conference had been taken place successfully. Previously, they had opened maybe 2 months before, 3 months before. Now the situation is not like that. So now, as far as our conference is concerned, now is 28th July. So 2nd September or somewhere around first week or second week of the September only, they will open the portal. That is number one. And we will intimate you timely manner. As soon as the portal get opened, we will intimate all the faculty, all the participants through email and also through WhatsApp that the special issue for GCRAism has been opened like that. And the second important thing is, when you submit your paper in materials day proceedings, you have to submit the same paper which you submitted as a camera ready paper to the conference now. Because we need to send the final program schedule to the publisher along with the paper title and author names and author order and submitting author email ID. In fact, along all these things we need to send to publisher. And while they open the portal, they used to check. Suppose if you submit your paper, they used to check whether your paper is listed there in the schedule, whatever program schedule, whatever we shared with them. with the same title and the same authors and also same author order. Otherwise, they will not allow you to submit your paper. Even if you submit, they will reject. They will not bring that into our knowledge as well. So they will directly filter out those papers which are not in line with the program schedule, whatever we have given, particularly the title and author order. So you have to be very, very careful in this. Whatever the paper you submitted here as a camera ready paper, the title, author name and author order, that has to be submitted to the materials day proceedings. However, the content may be a little bit different. That they will not take into account. But that you have to make sure. Otherwise, your paper will get rejected, and in that case, we will not help you. Right? We cannot help you. We cannot help you. We will not be in the position to help you. So please make sure this. And the next thing, plagiarism. Though we have accepted the papers based on the technical quality, technical merit, and also considering the less range of similarity score, there is a gap. Now you submitted your camera ready paper maybe 20 days back, and you are going to submit your paper in materials day proceedings around the second week of September. So 2 months gap. So over the period of time, everything gets changed. So everything gets updated. So you may think that you may have some update in your paper. But what I suggest is, please do not do that. Even if you want to do that, you do that, and please make sure, only in the content I am telling, not in the title. Please do not change even a single word in the title and the author's list. And if you want to change slight corrections in your paper, in the body of the text, you do that and make sure it doesn't affect the similarity. If the similarity goes high, it will be rejected. Though materials day proceedings, they will not reject it 25, because Authenticate is a most powerful software which detects plagiarism, and Turnitin is not that much, but still it's widely used and accepted. So you should not check your plagiarism through some commonly available, openly available softwares. Definitely it will have some huge difference. If you check some kind of free plagiarism checker, it will show 15% like that. But if you check in Authenticate, it will show 50%. So that much of huge difference will be there. So please make sure about this. So while checking the plagiarism, you use these two softwares, either Authenticate or Turnitin. I prefer Authenticate because Authenticate is the software which is used by Elsevier. While you submit your paper into materials day proceedings, not only in Elsevier, almost all the publishers, they are using Authenticate. So make sure. And another thing, with reference or without reference, we can argue with that. But publisher point of view, when we submit, they will not see whether which content got similarity like that. They will see only the score. If they feel that 45% is not, then they will remove the paper. Even if 35% out of it might be from references similarity. So what I am telling, instead of advising to the organizers or advising to the publishers about how the plagiarism came, arises, all those things, let us be very clear and let us be, let us make sure about those things will not come to our paper. So please check your plagiarism before uploading the paper. And once you are satisfied, if it is less than 25%, then only you need to. And the best way to reduce plagiarism in case of similarity in the case of references is, please follow whatever the references template given in the journal. Materials day proceedings, they have given, every journal have their own unique way of representing the references. So you follow that, then obviously it will get reduced. What people are doing, they are taking some paper from IEEE, some references, whatever the paper they are referring, those papers they directly take already available documents, they have the same format, same template like that. That only it will compare and it will catch. So please be careful. And also another thing, one week we will share you. So while submitting the materials day proceedings, they will ask you the acceptance letter from the conference. So either you can use the mail what we received, you just make it a PDF, and or you can use the certificate, presentation certificate which we are going to give. So that is mandatory nowadays, right? So along with all this and with clear content and also clear images and tabular columns, use high resolution images and tabular columns, right? So submit all those things. In between, we may ask you reviewers also. So those things will be carried on later, and we will make sure that the editorial process will be completed on time. Maybe within 3 months from starting. So maybe within 6 months, the proceedings get published. But nowadays, proceedings publication is not like instantaneous. Within 1 or 2 months, at least 6 months it will take. So we highly appreciate your patience during this time. So with this, any doubt if you have even after the conference about publication, all those things, you are free to contact us through WhatsApp. So we will be answering throughout the course until the entire volume get published. Okay, so we'll be happy to assist you. So with these few words, I would like to thank once again the AJ Institute of Engineering and Technology for giving opportunity to collaborate for organizing such a wonderful conference. This is second edition. So hope this edition also will be very successful like last time, and we will move forward. Thank you. Thank you, sir.
Thank you, sir, for summarizing about the conference. We witnessed the arrival of our keynote speaker, Dr. Dattatreya N. Goankar. May I request Dr. Ritin Kumar to florally welcome Dr. Dattatreya N. Goankar. Moving on, we have the release of the conference proceedings. May I request the dignitaries to do the honor. Thank you. May I now request our chief guest, Dr. V.N. Mani, to kindly address the gathering. Over to you, sir.
Thanks, madam. Respected dignitaries on the dais, respected faculty members, my dear students. See, a professor, a scientist, an engineer, a doctor differently thinks, alternatively thinks, logically thinks. Their thinking becomes ideas, ideas leads to discoveries, inventions. Silently, the society very much respects professors, engineers, doctors, scientists. Hence, I have little proudness. I feel happy I am a scientist. You should also feel like that. It is not that great politicians, film personalities, sports personalities are only respected. It's not so. They get a lot of media attention, but we are also highly respected. See, a very good concept. Now all fields are getting merged together, married together, become interdisciplinary, multidisciplinary. Everybody's efforts are required to rationalize in terms of high speed, high cost effectiveness, a person from humanity. First we should become a good human being, then becoming a scientist, sadist, or engineer is a different thing. So in that sense, the contributions, for example, a gadget like mobile, efforts of physics people, chemistry people, material science people, mechanical engineering people, chemical engineering people, EEE people, ECE people, even quality control people put their efforts. Maybe material becomes to chip, chip becomes to component, component becomes to device, device becomes to gadget, gadget becomes to equipment, system. Everybody's efforts are there. It is not only these people. So don't underestimate hardware sciences, don't overestimate software sciences. Now, smart technology, intelligent technology means both amalgamation of hardware and software. So MBA marketing fellow brain is also required to market the product. So only that is a trend. India is doing very well in software for over decades, 2 decades. We are very strong in mathematics. We are the inventors of zero. We are the heroes of zeros. Keep your patriotism aside. We are very good in English. 600 plus years, Britishers rule. Indians are smart, hardworking, sincere people. Good English, we are doing well. But we are not doing that much well in hardware. We have to go a long way. A great physics professor found out the reason on a cloudless day, sunny day, why sky color is blue. Because of scattering of different wavelength lights, blue wavelength, Sir C.V. Raman. He proved that effect by using physics concept and mathematical formalism. Alternatively, he has produced a small equipment called spectrometer. Experimentally also proved. Now, spectrometer, Raman spectrometer is a wonderful tool in deciding nano transistor, quantum transistor by having signature spectrum. Indian invented, he will show the way how to produce the machine, but we are importing Raman spectrometer. We are very good in science, good in research, poor in translating R&D ideas into meaningful application. Yes, Professor Tangaraj, Principal Sab, Madam Sab, they are doing their wonderful duty, producing good human manpower. But we scientists, engineers are lagging in that sense. The future generation will have a lot of scope in nanoelectronics, cloud computing, big data analytics, nanophotonics, nanorobotics, electronics waste recycling. These areas are amalgamated areas. A physics person has to solve. Mathematical person also required cloud computing, simulation, everything. Days where over superiority of engineering sciences, inferiority of basic sciences, then technology is different, technology innovation is different. Anyway, lot of scope. The organizers, your own faculty people, starting from principal office to might have worked minimum 6 months together to see the reality of this conference. Many brains, faculty people worked very hard. Even one of the faculty member is not required as per Western terminology. One faculty came to airport to receive me, but in Western countries, respect will be there. If mobile number is there, address is there, name, play card is there, enough driver. So that is the concept. Thank you very much. You youngsters should get benefited. Attending conference is one concept. Actively attending conference is another concept. I'll ask some students, how many conferences you have attended, how many symposium you have attended, how many workshops you have attended, how many tutorials you have attended means there is a difference between conference concept, seminar concept, symposium concept based on program, schedule, content, poster, so on. You youngsters get benefited. See, when Tanga Prakash, Madam and we were students, at that time there were only few books. We studied them, fortunately or unfortunately, whether necessary or not, across the spectrum, along the spectrum. At least we are thorough, our generation guys, thorough with concepts, fundamentals. I go to selecting of assistant professors in some good colleges and universities. That fellow is having 8.2 GPA. I asked one student, what is the difference between component and device? English letters, 26 letters, you arrange letters, you get words, you arrange words, you get sentence, you get sentence, you get paragraph, you arrange paragraph, you get some text passage essay. Very poor, I am sorry to say. And engineers, by fault or maybe reason, they are very poor in English communication skills. Now marks, now different world, competitive world. Marks alone won't speak. So you people should improve. This is the one occasion, possibly you attend all lectures if possible by offline mode or anything. Anyway, thank you very much. I wish all the success for this conference. God bless you and me and all. Thank you very much for the nice opportunity. Once again to the college management's organizers and Professor Tanga Prakash. Thank you very much.
Thank you, sir, for that valuable inputs. Honor is the morality of superior people. May I request our principal, Dr. Shantaram Rai sir, to hand over a memento to our esteemed chief guest, Dr. V.N. Mani, for gracing this occasion as a token of gratitude. also request our principal to honor our guest of honor, Dr. Tangaprakash S., for his valuable presence as a token of respect. I request Dr. Tangaprakash S. to hand over a memento to our principal as a token of love and respect. Give it to me. I also request Dr. Tangaprakash S. to honor our organizing chairs, Dr. Kiran Kumar VG and Dr. Sangeeta DM. Thank you. I would maintain that thanks are the highest form of thought and that gratitude is happiness doubled by wonder. With this, may I call upon Mr. John Prakash Vegas to give the vote of thanks. Sorry, may I now request our principal to give away the presidential address.
Always man make mistakes more perfect. Respected dignitaries on the dais, my dear researchers, participants from various parts of the country as well as the outside India, respected head of departments of the AJIT, my dear faculty members, members of the Research and Development Committee of the AJIT, my dear faculty members and students. We, the AJIT, the family of the Lakshmi Memorial Education Trust, which started in the year 2016. It is an institution, basically the engineering institution grown up with very fast and produced already 2 batches of quality engineers and succeeded in placing in the different places of the country as outside to start their professions. This is only possible because of the, not only from the curriculum, by conducting or the providing a platform for the different technical as well as research platform for the researchers as well as the students. On the part of this, today you are inaugurating the 2nd global conference with the support of the Dr. Tangaprakash and his team. Last year during the pandemic, in the verge of the completion of pandemic in India, we were able to succeed without any hurdles to complete the first international conference. In fact, in the Mangaluru region, we are the one among, we are continuously organizing the international conference, attracting the researchers from throughout the world. As Tangaprakash sir rightly said, we are receiving the good quality papers. Most of the conferences are, even though they are conducting, they are not getting the quality papers, but it will be, we are getting what we require or what may be the, we are struggling to shortlist what is required that one because of that much overflow. We are closing the certain conference well in advance before the last date itself because of overflow of the research papers. But once it is present, as rightly said, obviously as AJIT also means the qualities matters. What we are giving for our faculty as well as the students. Writing the paper is one part. Second thing is afterwards, bringing to the quality without any plagiarism or maybe in the frame of the research content. Nowadays, there are so many papers are coming with the different journals, but the qualities matters. But what maybe the conference were organized last year, that the first conference, almost all the papers, what we are presented in our conferences, I think more than 250, all the papers are accepted by the LCR or the IOP Science. It's a great achievement of our conference, what the quality of the paper is shortlisting. We hope the same thing will happen for this conference also. Coming to our institutions, the quality we are not compromising because of that span of the 6 years itself. As mentioned during our introduction, the institution is identified as the University Regional Center for the Mangaluru region, as well as the coming to the Atal ranking of the Government of India. So we are in the 6th year also. We are placed in the brand promising institution in India. Usually it's very difficult to achieve that one itself. AJIT is identified during last academic year, brand promising. Again, you are passed to next stage. We are going for the next brand excellent, that one. So most of those who are complete 20 or 25 years from their inception, they are not achieving this achievement, since that matters quality. Coming to other part of that one, we are the AJ Institute of Engineering Technology. During last academic year, we were identified as one of the best engineering college in India, which is reviewed by Knowledge Review magazine. Same time also, what system we are adopting with respect to technical, maybe supporting for the students. It may be in the form of the conference, or maybe in the form of workshop, or maybe in the form of the technical talk, or maybe in the form of seminars. It is different, as our scientist rightly said that everything have a different concept. What we are getting from the attending the conference is different. What you are getting from the attending the seminar is different. What you are getting from the workshop is different. If you go detail about that, you will feel that. But if you are not able to attend, you are not attend that things, you may think that everything is same. But we are giving the platform for our researchers, including students, scientists also. With these viewers, once again thankful to our chief guest of today's function, Dr. Mani sir. He's a very old man. I think before itself, we are coming here, he wants to interact with the students. He wants to share the knowledge. Okay, discuss some of the students. Still is very dynamic person compared to us. So really thankful, sir, for attending our campus for especially for second global conference. And same time, Dr. Tanga Prakash. We met last time. We had a casual discussion. Actually, we had a plan to conduct the internship conference. Organizing internship conference not that much easy. Everybody, those who are involved, that one will be there. The pre-conference to post-conference. And same time, it will be the gathering the research quality papers. That also matters. With the support of the Dr. Tanga Prakash and team, it will be. We have successfully passed the first global conference, and we are continuing with the second today. We are inaugurating. And hope we will continue for every year. The number will continue as long as we are here for the AJIT. Special thanks to Tanga Prakash and his team. So AJIT will work with the support of all the faculty members. We are making a quality for that, including students also will be. What you people are expecting, we are ready to give. Same thing we are supporting for the neighboring institutions also. What is required, what we can give for students, especially in the form of the technical knowledge or along with the supporting research work. We are having very good infrastructure, very good facility with respect to the private institutions. From that only it is possible to organize like these conferences. Once again, thanks for all the participants on behalf of our AJIT family in my capacity of the principal. And thank you all. Hope you will enjoy for the next 2 days. And all the participants, those who are joined in the online, they will enjoy the session without any problem. It is possible because of our AJIT team. Thank you all.
Thank you, sir, for that presidential address. A grateful heart is the highest form of virtue. May I call upon Mr. John Prakash Vegas, R&D coordinator, to give the oath of thanks.
Good morning, all. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I, John Prakash, organizing member, GSC RDCT 2022, feel honored and privileged to propose vote of thanks on this special occasion. I, on behalf of Team AJIT, convey deep regards to our chief guest, Dr. Mani VN, scientist, CMAT, Government of India, and Dr. Dattatreya Narayana Gaunkar, HOD, Department of E&E, NITK Suratkal, for gracing the occasion. Thank you, sir. Thank you, sir. I sincerely thank Dr. Tanga Prakash S, Director of Diligenic Solutions and organizing partner of GCRASM and GCRDCT 2022. Continuous support from your team have greatly helped towards the successful organization of this conference. Thank you, sir. I, on behalf of the organizing committee, convey hearty thanks to our President, Dr. A.J. Shetty, and Vice President, Shri Prashant Shetty, sir. Thank you, sir. I am thankful to our principal, Dr. Shantaram Raisi, for his mentorship and constant support throughout the conference. Thank you, sir. I would like to thank all the invited speakers and honorable delegates who blessed us with their presence and for their enthusiastic participation in this conference. I sincerely thank media partners, V4NEWS channel for live streaming of the program. I take this opportunity to thank all the program advisory committee members, technical committee members, and reviewers for providing their valuable comments in time and help towards the improvement of quality of papers presented in this conference. I am thankful to all the session chairs and session coordinators for their support during the conference. I am very much thankful to all our R&D members for their constant and consistent support throughout this journey. I acknowledge the unwavering support received from our HODs and colleagues, non-teaching staff members, student volunteers who always stand by us and motivate us. I once again thank everyone whose contribution has made this conference a successful event. Have a great time at HIIT Mangaluru. Thank you, one and all.
Thank you, sir. Here we have come to an end of our inaugural program. Thank you everyone for making this event a successful one and wishing best to all the participants, and we are indeed delighted to offer the most hospitable welcome we can. Moving on to the next, we have the most awaited keynote sessions by two eminent personalities. I request our chief guest, Dr. V.N. Mani, to start over the session. Over to you, sir.
electrolysis, electrorefining, then normal freezing, all these things. Ultimately, class clean packaging, not exposing to the environment. So in our laboratory, we have 3-4 major programs. Taking low grades germanium, a wonderful semiconductor materials. When transistor was invented, people used only germanium. But later on, it's optical material. Material intrinsic properties, band gap and other electrical characteristics decides which material suits to what application. Now, microelectronic material means 99% silicon. So, low grade silicon, electrochemical routes, metallurgical routes, freezing, quenching, solidification, normal freezing, controlling solid liquid interface, playing with diffusion mechanics, mass transfer mechanics, creating all these things, crystallization, chemical engineering. Then ultimately, my dear students, whether you are a civil engineering student, IT students, ultimately, in this world, there are different materials. Brick is an example of ceramic material. You should know materials classification. Ceramic material, composite material, plastic materials, metals, alloys, compounds. Okay, organic materials, inorganic materials, mainly semiconductors rules the technological world. Information technology, communication technology world. Silicon, germanium. My dear students, nowadays, whether you are from civil, mechanical, whatnot, if you are going for an interview, at least you should know, because you are dealing with variety of gadgets, no? Basic material silicon, germanium, some related zinc oxide, gallium arsenide, indium phosphide, oxide, zinc oxide, maybe silicon carbide. There, where it comes, what is the p-type material, what is the intrinsic, extrinsic, no zero use of intrinsic. You have to make it p-type, n-type, you have to dope it, how to dope, how to convert amorphous to crystalline. Any third year students are there, triple E students? They can raise their hands. Easy. Oh, this is the problem. Then I would have, okay, then going. Somebody will operate the slides? Not you, sir. You are a faculty. Young, bright guy. He is only guy sleeping stage. Go and operate my slides. Come. Hey, don't really. I am also sleepy. Steps. Only you have to do, whenever I see your face, just press this down arrow button, no? That's all. You want chair? In this country, see, I am not enemy of software. I am not friend of hardware. I am not enemy of engineering technology. I am not friend of sciences. But then, present day world, all fields got merged together, married together, become interdisciplinary. No superiority complex, no inferiority complex. Even MBA fellow is also required to market the product. But then, in this country, now scenario changed 20 years. A BA English literature fellow won't respect BA Kannada fellow. BA economics fellow won't respect BA literature fellow. BSc physics fellow won't respect BCom fellow. That BE civil engineering fellow won't respect chemistry fellow. Then triple E person won't respect mechanical. No, it's not that. Say, my dear students, the success of our Indian space programs, missile programs, first credit goes to mathematicians. Because the computational, maybe calculation, modeling, predicting the path, which direction, so on. I am not a mathematician. So I can tell a butler. Physics people, materials people, detectors failed. The rover, material strength failed. Maybe guesstimate. I don't have any. Those are classified guesstimating. Scientists can guesstimate, professor can guesstimate. No? Detector failed, material strength, fatigue, whatever strain, something failed. So materials, pillars of modern technology, no denial. So you are in which department, Guru? You are a research scholar, no? Feel very friendly. You are working on what type of materials?
Department of Marketing and Logistics.
Good. See, colloquially, as a comedy type of Dr. Mani, keeping my status, age, little bit away for some time. How to understand the concept of science or importance of science, concept of engineering, concept of technology, technology innovation, even concept of human beings. Ethics, integrity is missing. Even though if I become a very good engineer, doctor, scientist, if I morality, self-morality, confidence goes, no, humanity is also important. Don't underestimate. So science or humanities can be maybe roughly taken as an example are children. Science subject, humanities subject can be equated to children. That children, boy or girl, science or humanities. That boy or girl grows, becomes a man or woman, that is engineering. That man or woman grows, becomes a gentleman or a gentlewoman or lady. Maybe technology. Even productive human being, more productive performance, maybe technology innovation. But then, so don't underestimate sciences. Don't overestimate hardware sciences. All got merged. If you are not, maybe you are ill-treating your baby, from that baby only you should get a gentleman or gentle woman or lady, whatnot. So that trend is interdisciplinary. So we have seen England's Industrial Revolution, Manchester, all mechanized, automated, then mass production came, that steam engine, whatever, 18th century. Then software started slowly merging with hardware. The machine concept changed to instrument. Then even smart nowadays technology, instrument is becoming smart system or whatnot. How intelligently you are merging the existing, the standard, rugged Russian concept of hardware with emerging software to maneuver, to tailor the properties, application, that is instrument, no? So then smart everything. So in that sense, machine concept differs, instrument concept differs. So that revolution. Now maybe mass production, cost. See, research is different concept, research and development is different concept, pilot level production is different, manufacturing is different, mass production is or whatever. Not difference in terms of spelling difference, words difference, pronunciation difference. Where, how intelligently, more yield, less failure rate, mainly your marketing fellow, no? Mainly cost reduction. Suppose a scientist, I have been given to purify indium metal, let us say, 150 degrees centigrade metal, 3N grade, 99.9% purity using atomic spectrometry, HC, PLC, chromatography, you can know the purity of that. But I forgot. Absent minded. What I told?
Purity.
Oh no, sorry. Suppose a technologist, a pilot level, real technology means if my input material is 1 kilo, if I get at least my output material somewhere 400 grams, that is wonderful technology. Yield. If I take 1 kilo, if I get only 10 grams of high quality, that is not technology. Where? There, now we are strong. That is the thing. Now there is, then railways came, computer, microelectronics ruling now. But then in India, the problem with our scientists, professors, not everybody, each decade a subject will blow up. Superconductors, you spend money. Nanotechnology, you spend money. Like that. Nothing will come, some papers. Including me, I am not blaming you. But existing technologies, macro technology, micron technology, silicon technology existing, which took 50 years to mature enough. Now silicon technology, microelectronics technology has been proved cost effective, failure rate has come down, size shrinked, what not, size, shrink, everything. But then emerging nanotechnology will marry together with existing electronics technology, will give a new baby called nano electronics, nano photonics, nano optoelectronics, all are English jugglery. But then definitely technology forecast study says that definitely nanotechnology is in the research doing wonders in nanomedicine, nanobiotechnology. But definitely nanoelectronics, there are some ground infancy research in the advanced lab, but it may take another 10 years revolutionize. A simple IT students, instead of going detail, now you have a laptop. Oh, this mobile, you see what? How many mobile phones you have, madam? How many cell phones you have? What is the difference between cell phone and mobile phone? Like house and home. That's all. Now there is assume components are there: transistor, diode, capacitor, resistor. No electronic student here. Any single student, ECE, EEE, raise their hand. No. You are ECE, madam? What is the difference between 43 grade cement and 53 grade cement? No, 53 minus 43 equal 10 is the difference. See, madam, why I talk not like that? Components are there. After packaging few centimeters, then it comes to some centimeter. Because this is used already existing macro components, size components. In another 5 years, the nano components, after packaging maybe microns, now after packaging in millimeters, the size will become as a pen drive size. Nano means superior property starting from density to melting point to boiling point to specific heat to mainly electrical conductivity, optical. Any student or any students, 2 or 3 properties only in the application matters. For electronics, mechanical engineering, electrical conductivity, refractive index, there thermal conductivity, thermal tolerance, physical property perfection, chemical purity, inclusions, removal perfection, then these matters. This applies to not only your electronics, it applies to civil engineering, even mechanics, everything. In that sense, nanoelectronics will have a better future, cost will come down, 5 times faster than mobility. For example, now you are trying for Anushka Shetty to talk to her, lovely talk. If she is in Mumbai, it takes 1 minute, but if you develop such high quality materials, the moment before touching the screen itself, she will be on the line. Speed, because detection ability, sensing ability, every student should remember the technology, irrespective of disciplines. Sensing ability, detecting ability, resolving ability, speed, sending. These are the Taraka mantras for civil engineering. People may not be knowing, they think that is different, only cement, only sand, only iron, only, but electrical materials, copper, silver, great, then that fellow, platinum. What's your name, madam? Don't feel I am like your father figure. This less died. The chain you are wearing, don't feel bad. A science student, engineering student, technology student, a scientist, a professor, a doctor should not be sentimental, fool. Should not be sensitive, should not be fanatic. There will be ups, few. There will be many downs. There will be more failures. There will be less successes in their careers, in their life. They should follow take it easy policy. Now the question. This chain you are wearing is covering gold or real gold? For this 1 hour you reply. That means definitely it will be covering. Real gold, then the question comes. See, gold, a metal, you should ponder over. 1 kilo gold, let us say ornament gold, 22 carat, somewhere 97. 1 kilo gold cost is roughly now some 60 lakhs now value addition. But that is a metal, costly metal, precious metal, costly. Platinum also, even more. But same aluminum metal. If you go to vessel shop, Anda, Gunda, Dabra, good quality aluminum maybe 300, 300 or 400, dure aluminum, whatever, maybe mixers because of not more than 700. That is also metal, this is also metal. Why this is costly means there may be some reason. You find out in the net. I know, but then the reason, those kind of, for space electronics, defense electronics, not only semiconductors, not only germanium, not only silicon carbide, high band gap material, high temperature application, high frequency application, wide band gap, but high quality, high purity, gold, silver, gold paste, palladium paste, and mainly these materials doesn't come easily. You have to take suppose 10 kilos, you melt it, freeze it, then refine it, purify it, cast it for bar making. The yield problem, loss problem, then removal of waste, then you get it. That's why costly. Of course, abundance, processing cost. To process, to get 1 kilo gold, you have to get 1 lakh kilogram gold ore, you have to process it. Roasting, cleaning, rinsing, washing, pickling. Then finally, it involves money because then casting, that is the reason. So nanoelectronics means, nanorobotics means not simple semiconductor materials, apart from technologically important materials for different thing. Next. I have not started my lecture so far. Next, madam. Next sub. Say, for example, my 3 children are doctors. Elder boy is MD completed last month. Now he is doing senior resident doctor. My second son is doing MDS oral maxillological surgeon. Daughter is completed BDS. He is trying preliminary. That is not self-dabba. Suppose, so far my elder son not got married. If my elder son married, I get a grandchild. Assumption. Then maybe that grandchild married with Aishwarya Rai, her own daughter, or maybe her near granddaughter, whatever maybe. Her color, mine is Ravana color. I am friend of Ravana, because Rajinikanth. Only Shivaji film, by animation, everything will be shown. Why it is, but in reality, he is a friend of Ravana in everything. But then, hybrid. So, like me, my grandchild, through Aishwarya Rai relative, whatever girl, let us, she is old, I think. Her daughter cannot be married, I think. Leave it. But then, not too darkish like Ravana color like me, jeans, not whitish. I say in between, no? Hybridization, hybrid technology is the concept going to emerge. So far, very large scale integration, integrated circuit fabrication, so many steps. EEE people knows, which I also don't know fully. But then, screen printing, poster printing, cinema poster printing, everything, mixing technology, thick film technology. That is the real. That's why different materials. Suppose if the earlier trend is marrying Aishwarya Rai daughter with Tamanna daughter by Tamanna son, same color, everything, cinema, everything. But then marrying Tamanna daughter to my son's grandson is somewhat hybridization. Different materials. Silicon alone was investigated. Germany was if possible. Silicon Germany, if you mix it and obeying the Vigard's law, solidification, what is that? Solutal gap or miscibility gap, phase diagram violation, everything. Then definitely it may not be silicon properties, it may not be individual germanium properties, small area only phase diagram difficult. There are limitations. Then that is the concept. Platinum is a wonderful technological material for space electronics. Diamond is a wonderful material for defense electronics. And mainly glass is a wonderful. I have not started, madam. Next. Quick up on. How many more minutes, madam? Oh, professor, that is the problem. Any younger speaker I can dominate, but he is a godfatherly figure, no? You go and sit up. Say, it is not that interdisciplinary research starting from hardware to basic sciences to advanced sciences, everybody role, it plays a dominant role, strengthens your hardware technology, later lead to mixing up hardware, software. A software fellow getting 1 lakh rupee, but for that physics fellow, chemistry fellow, materials fellow, everybody has put to effort. Once we give, I am not criticizing IT, but once we don't give gadget, software, laptop, what you will do, think of. So you change the superiority complex first, then we will slowly remove our inferiority complex. Or multidisciplinary, special, high purity, high perfection, physical properties, high electro-optical properties, thermo-optical properties, then those kind of things, different materials. So I told impurities will change your optical properties, electrical properties. Ultimately, that material-based component device, when you are using in satellite, may not function, performance will be there. That's why purity. Picogram, 10 power minus 12 gram. 10 power minus 9 gram, nanogram, picogram, that is the level. So, for space electronics, then packaging, you should not expose the material that you are going to use that material for producing a component for special missile application, then that is the level. See, device, now you are enjoying. In one way, this electronics technology, communication technology, information technology has given lot of luxuries to the society, but this technology is spoiling, especially you generation. One way dangers. But electronics technology was different, optics technology was different, light field was different, electricity field was different. Both got merged. This is the real wonderful achievement. You can convert light into electricity or vice versa, solar cell, fan, everything. But human, say once again, because of time, so think of God-given example. A sea eagle or kingfisher bird spots its prey, fish, it is in the water, but compensating diffraction of light in the water, then using that high speed level, sensing ability, detecting ability, resolving ability, then it catches prey. Similar properties are realized producing components of high quality purity other than silicon like gallium arsenide, indium phosphide, such components produced to special grade detectors and all these things. So nanotechnology has the potential, then I'll skip it. Anyway, I'll give some ECEEE students in future, I'll give a lecture even, but give the slides. The developments in the past 50 years, no time. This slide I want to tell cheap, superior performance, but ruggedness, stability, facing the dissociation is the challenge. The scientists will address those things in another 5-10 years. Then nanoelectronics will be the talk of the town at least 20-30. So, say two concepts. Existing macro technology, bulk technology, micro technology is one concept. Using smaller machines, using bigger machines, producing smaller or vice versa. But high accuracy, high control, everything. Packaging also wonderful thing. It applies to civil, to mechanical. How intelligently you are utilizing maximum available, minimum available space for maximum packaging your components. That is the wonderful area. Any students in future, claim recovery, cloud computing, big data analytics, and this packaging is wonderful areas emerging. Even Max Fellow, Physics Fellow will. Anyway, I'll skip it. Only 1 minute, madam. See, as I told, our defense agencies, space agencies require certain select materials in small quantity, high purity material. In our cement laboratory, we receive low grade material, low purity material. We apply starting from chemical engineering, starting from electro refining, maybe pickling or distillation, all these things, metallurgy and everything. Ultimately, we reduce the impurities to make the material in pure form. That pure material will have better required electrical optical properties. Then we package them. We study their characteristics, especially purity level in parts per million, parts per billion using spectrometric ICP-MS, GDMS. Then we test many material electronics application, means electrical conductivity and all these things. Especially the space defense high level applications. Okay, anyway, we have material gallium. Any student will answer why mercury is a liquid metal, but aluminum is a solid metal. Which property decides a material to be in liquid state or solid state, or structure of the atoms, or binding energy, bond strength? Why sodium chloride is dissolved in water, why not in coconut oil? Because of density, no. Kerosene also not, then ionicity and whatever polar solvent, that kind of things. So we take certain materials, apply all refining technologies, purification technologies, nano purification technologies, then filtering technologies, clean packaging technologies. We test all the properties. Ultimately, we certify a material with third-party US or Canada analysis. We hand over to them, and they will produce polycrystalline material or crystals. They will produce devices. Our role is producing high-quality electronic materials for enough, madam. That's all. Time factor. We do a lot of simulation studies to optimize optimum temperature gradient, optimum zone depth, all modulation. And no equipment, no system required to purify, process these material to ultra purity material will be supplied to India. No high purity material in large quantity will be also supplied to India, because nobody will do with such 7 impurity material to publish a paper and do research. Waste. So we have to develop our own systems based on our limited publication data, patent data, multidisciplinary, instrumentation engineer role, mechanical engineer role, chemical engineering role, physics person, phase diagram, everything. So that's all. See, when the medical ran back, say chip locks, Reddy laboratories, when they package capsules, tablets, injections, they will use certain glass clean room with controlled humidity, room temperature, and particle size 0.5 micron. They filter out with HEPA filters. If there are some impurities there, it goes into the injection material liquid, then you will go to Swargalokam. If that is the class 100 level, space purity material, electronics, equipment, system fabrication requires class 1. It's crores. If one impurity will change your, then I think enough. This is the best slide, madam. Okay, thank you very much. Once again, I thank the organizers and Professor Tanga Prakash for giving me the opportunity. But some other time I will come, madam. Especially, this is a different audience, no? All right. So, any questions? Don't ask. Thank you very much, Professor, for delaying. No, thanks. Sorry, Professor, for taking you some time. I thought first 75 minutes will be there. Yes, Professor, you can take over, Professor.
Sir. Sir is very jovial throughout the session, and he is very much interactive with the students. And in the same way, he expects some questions from the students as well. So
Oh,
he'll
one
be
or two
available-
questions for satisfactory reasons from students. Short but should be quick. Flash type questions. Oh, it won't come? Then I will take it to Hyderabad. Yeah. Some problem this morning
He'll
also.
be available throughout
One
the day
young,
here. So
one young floor.
if any questions or queries are there, you can
Shall I
interact
give
with
my
sir.
shot? Prove one or two questions. What is the formula for area of a circle? Pi r square. What is the formula for area of a square? Maybe r square or a square. Where why pi is not coming in square means that is the rocket launching philosophy. Positioning your satellite in the orbit, escape velocity, whatever may be. Why not A shell, B shell? We'll cut it.
Who has played startup? Say, one student asked me one question in some conference. Atom structure, no? Center nucleus. Proton, neutrons, protons are positive charge particle. The partnership between number of protons to equal to the number of electrons. Neutrons chargeless. But electrons revolve at the shell based on energy conservation. That shells are K shell, L shell, M shell. Why not A shell, B shell, C shell? You are asked me. I never answered at that time. You find out the answer in Google. First. which may require to charging as well as discharging. Okay, so that is the kind of a scenario which is going to come in the coming years. Okay, so this how this kind of technology will get impacted by the material, okay, the requirements and other things is very important. Okay, so that is why the materials become a very important playing very important role for this kind of technology. Of course, there are so many informations there in the slide. Okay, and then another things you might have heard about smart grid and other things. Of course, we talk about smart grid. People might be, when I say smart, generally they think of IT. Okay, anything which has got an IT or some kind of computer things, we may say smart. How your mobile. Okay, there are many things. Okay, how your household gadgets becoming a smart. Okay, all these are because of the IT and this thing. That's how we feel when I say smart grid. But it is not the only IT alone. Okay, it is not the only IT alone. There are several other things which you require. Okay, nowadays people talk about AI and machine learning and other things because we want whatever we do, interact. We want the other side also interact with us like how we interact. Okay, this is true for any kind of things. Why the smartphones have becoming so popular? Because it has certain things where we need those kind of features which were not there in the conventional mobiles and other things. Same thing is with respect to the grid. We also want our grid to interact, how we interact with others. Okay, that's where there is the machine learning, so many things are coming up. Okay, so that's where what I call is the smart grid. It is not only an IT alone. There are so many things that the grid has to respond way in which we are responding to others. Okay, the human being interactions. Okay, so that's where the smart grid technology is. So we will see more and more renewables there. These are the technology. One of the important technology is the electrical vehicle. Okay, and that is going to come on the grid. And the renewable, apart from that, we want the system get automated. All these things like household gadgets as well as our the distribution system, everything get automated, and also will the monitoring and other things. Okay, so that is what we expect in case of the smart grid. Okay, so these are the technologies in the smart grid. Okay, this is what is the current more of multidisciplinary rather than focusing on one department. Okay, all kind of the things are getting evolved in terms of what you call a multidisciplinary engineering, where we do require support of all the departments. Okay, so this is not going to be one kind of things. It is requires all kind of the support of different kind of technologies. Okay, so whether it is the fuel cell, whether it is wind, whether it's a solar, all kind of technologies are required. Okay, so there are of course I will not go into detail about the various technologies. Okay, so there are so many technologies which we can think of when I say renewable. Another thing is the storage technology, because when I say electrical vehicle, the battery is the one thing. Okay, now these vehicles, scooter, all this is becoming so simple just to have a battery. Okay, there is that old mechanics, the kind of things like the mechanical system. Yeah. 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 So. Yeah, that's rightly said. The battery is going to rule all of your vehicle, and there is the another thing, that is
it requires a material. Okay, that is where the problem. Okay, why the battery technology? People have tried all kind of materials available in the periodic table. What they're doing is they're combining various materials to get better performance. What you expect from a battery is it should give you a long drive. That is, it should not discharge so fastly. Okay, and the size of the battery should be very small, so that you can accommodate wherever whatever the space available, whether it's in your car or scooter or wherever this thing. Of course, the battery technology is not new. This is already we were using a long back, but the material played a very important role in this battery technology. And that is where the India is, still we see the lithium ion batteries are much costlier, okay, because, yeah, understood, okay, yeah. This is the technology. Of course, apart from battery, there are so many things like semiconductor, the technology, and also these old mines where the land which is used for mining can also be used as a storage. Okay, many of us may not be knowing, but that has a huge potential. You can store air in a compressed format and use it. Okay, that can be at a very bigger level. Okay, and then there are so many other kind of storage. Of course, apart from a battery and the supercapacitors, all other storages are not what you call, except this conventional storage in terms of the air storage or the pumped hydro and other things. All these other technologies are not that much developed. They are all in the what you call demonstration and other stages. Okay, so of course this becomes very important. Same battery which is sitting on your car can also power your load requirement in the house. Okay, so that's what people were talking about, V2G. I don't know how many of you heard about grid to vehicle, vehicle to grid. It can either take from grid or discharge back to the grid. Okay, so that is what is the technology which you are talking about. Okay, the same battery can act as to power your load as well as to power your vehicle, and the charging and discharging are required as a part of that kind of a scenario. Okay, so that's what about the storage. Here, as I told you, we'll come back to that the material plays a very important role for this battery, and as well as the supercapacitor. Okay, and this is what is the expected things. Of course, I will come back to this later. Now we'll talk about various technologies. What is the role of the material? You know, the wind system, wind power system. Wind converts the kinetic energy, that is, this kind of system converts the kinetic energy available in the wind to a electrical energy. Okay, through what you call a wind turbine and generator mechanism. Now, why wind system is so costly? Is because of the materials as well as what you call the technology involved in it. The blade design, it is not similar to design like our fan blades. There is a lot of differences there. Okay, of course people are developing the wind system on their own hobby scale, okay, which may not be what you call addressing many issues. So you may feel that it is very easy to use the blades, those kind of things, but it is not so in case of the wind power system. Okay, of course most of things were imported by China. Okay, this blades, of course, in a larger scale, India is the few companies are involved in developing, but still the technologies, many of the things are taken from China. Okay, and another thing is most of this wind turbines are going to become a permanent magnet-based system. Okay, so they are going to use a permanent magnet generators, where India has very less resource of these materials. Why China is ruling all over the world? why almost all manufacturing sector has been gone to there is because the availability of a resource there, which many of the countries are lacking. That's why you still depends upon whether whatever they say, most of your gadgets which you are using, either they manufactured, everything is at the China, or they covered at other places. Okay.
Sources means raw materials.
Yeah.
Not budget.
Yeah. That's what I am talking about. The raw material. The raw material for a magnet. Okay, in case of the wind system, you see there are so many things in the wind. I will not go into detail. Yeah. I am not going to detail about the individual section of the wind, this thing. I am only talking about the material used for this kind of system. The blades, the generator material, okay, and many other things. Of course, these magnets, which generally they are used in this, we do not have much source of those materials. Okay, whereas China already has a lot of reserve all those material. Why they have become so much this one? Because we are depend upon them for the raw materials. Okay, so that is the one thing which, and also another thing what they did, good thing is they acquired most of this raw material source other part of the world also. Okay, many countries. Yeah, many countries they have acquired already. Okay. Yeah, they have already acquired this under their name. So that's why is the problem. Okay, we still depend upon them because we need that raw material which we were not aware that they were used for, because we have thrown those materials during long back. Okay, but yeah, as Professor rightly said, he has already introduced those materials, but all these are in the China, or it acquired those kind of things many part of the world. Okay, so that's why the manufacturing these raw materials are still concentrated there. And this is what is the material things which, of course, I am not expert on material. I work on the system. Okay, so not on the material side, as the professor, he is completely involved with those material. He knows what is, yeah, how difficult and what are the materials and other things. Okay, so these are the list of materials which are used in a wind system. Okay, and especially the magnetic permanent magnet material. Okay, these materials are why the wind system is so costly is because of this kind of things. Most of these are part by part imported from China. Okay, that is where we are still depend upon them. Only I think Suzlon or Vestas, they were having some, I think even near Padubidri something they were having, but still many things are imported from China. Okay, so why the wind system is very costly is because of this kind of things. Okay, and future it is going to be more a permanent magnet rather than any other kind of generator system. Okay, so that is where the material usage in case of the wind system. Of course, people were not thinking about this material earlier. Suddenly this became much popular because our depends, most of technology is going towards using those materials. Some of them are called, you might be knowing, rare earth materials. Rare earth material in a periodic table. Now all this materials have become very important for our renewable energy. Critical materials they have become. Earlier, we were not knowing the usage of these materials. Suddenly they become so much popular. Okay, and because lot of the things are there, so we are depend upon those material now. Okay, so we require a lot of material for a wind system. Of course, I will list it. I will not go because I am not the expert on those. And the magnetic material, the top two material I have listed there, which are going to become a very important part of a wind system. And we do not have a reserve of those materials. Okay, so that is why most of the permanent magnet generator are imported from China. Okay, and if you talk about rare earth material, around 70% of the rare earth material, 60 to 80% in that range is with the China. Okay, so these materials have even US or other countries also depends upon them for this material resource, and their usage is going to increase. Okay, so that is what is the thing. You can see what I say is a rare earth materials, okay, which we were not knowing the usage earlier, okay, which becomes a very important part of wind system, the permanent magnets. Okay, yeah, yeah. That's what after going through several communication computer revolutions, now we are trying out do the materials. Materials become so important now. Okay, especially energy sector. The materials have become so important for the energy sector. Okay, and then this is the another one technology, solar. Again, we require lot of improvement. So professor was telling, the doctor was telling that so many things possible with required for the solar cell. So many materials. Okay, you know, I think many of you, whether you are belong to civil, mechanical, electrical, all you might have seen solar rooftop on your own house rooftop or somebody else, or in a big apartment and other things. So solar is not a, yeah. So it is not the one particular department, this thing, it is all now a multidisciplinary things. Materials are involved, so many things are involved, mechanical, all the departments are involved in this kind of system, energy system. Okay, so you can see the solar cell, it requires efficiency, depends upon the material what you use. Of course, the currently available solar cell, hardly it has 14 to 17% efficiency. You remember? Yeah. It can be there up to 25 years. Okay. So already the efficiency is only a 14 to 17%. Suppose if you improve this efficiency to very high value, 40 or 50%, you imagine the energy from sun is freely available. And if you improve the technology of the material there, if you harness it to a very high efficiency, you see almost all your requirements can be powered by sun. The problem in this is the material. It is not the other part of it. Okay, we have all other part, but the problem is the bottleneck lies in the material what you use. Okay, the currently available material, okay, which is more silicon dominated, which is 90% of the things, which has efficiency around 14 to 17%. Some people, yeah, that is available in the this thing sand. Okay, and another thing is people have quoted recently around 20 to 25% using the cadmium telluride cells, but these materials are not available with us.
More scarce.
Yes, that is where the problem. Okay, the cadmium telluride, which can yield to higher efficiency, is not available with us. Yeah. So that is where the issue. Okay. So if you want to higher efficiency, you can power entire world with solar only. You don't need thermal. All your climate problems, everything goes up. But bottleneck lies in the material. If you improve, of course, people are doing a lot of research, not at the material level. They are all at the connecting and other thing, but still bottleneck they are not able to address. This is only at the high research level they're trying to improve the material and other thing. That's how the Dr. Mani was telling that the material has become so important for us. Okay. Yes, that's why nobody is in. If you ask any Indian any university, do you have any research on materials? Nobody is doing. All are at the higher level. Bottleneck is still lies. Whereas some of the top research laboratories, they are working on the material. Moment they get the material, whole world will be depend upon them, their technology. That is how things going to happen. Okay, their research, they may not get immediate output immediately, but people want things immediately. Whereas if you work on material and other things, it is not so easy to get the result. But moment you get, you will become a world famous to get that material. Everybody, every country will depend upon you. Okay, so that is where the importance of those things, and many where they are trying to improve this efficiency of a solar cell. Efficiency of the solar cell. Moment if you do, you can replace the conventional sources. Okay, and of course, this is what is the material requirement for a solar cell. The below things is the requirement of a solar cell, where these materials, we do not have much resource of this material. Okay, so try to we need to improve the efficiency of the solar cell. The top one is shows the important material for solar cell. Yeah, yeah, that is the drawback. Okay, whatever way you want to take over the other this thing, but we are going to depend upon them because we do not have the resource on this kind of materials. Okay, so of course the another important thing is battery. Now people, anybody you talk, they say lithium ion, lithium ion, lithium ion. Okay, why lithium ion? Because it has a better property than the compared to your lead acid battery. Earlier we used a battery technology long back. Battery technology is not new, but way in which it has come is the new material. Yeah, lithium dangerous, but we need that to improve your efficiency. If you say, if you are driving a car, suddenly in the middle your charge goes out, how you feel? Okay, so you may not able to depend upon such things. We want something which can reliable and which can drive you along. Okay, which can give you, yeah, you can give, it requires. Why people were not explored that idea is because of the problem in the material and the technology there. Now why? Because there is a lot of improvement. Every the material in the periodic table, they all try to club to get the better, and then they found out this is the one thing which can, of course there are further more advanced things are also happening. Lithium ion becomes so powerful now that, but India do not have this resource. These are rare earth material. This comes under the category of rare earth material. Some of the country like Argentina, all this Chile and other things, but those resources are already acquired by China. Okay, so we still, the world has to depend upon them for the material. If you want to improve the performance, okay, most 80% of the requirement of a lithium is supplied by China. Okay, and the technology is based on the material, the lithium ion in the battery. You know, nowadays every car, vehicle, you are in a household, people started supplying lithium ion batteries. Why it becomes so costly? And other thing is because of their what you call the material involved in it. Of course, as the professor said, it is also kind of the problematic also, but we need a performance. Okay, we want, because you know, when a computer or in a your mobile something, when you try to call, if it is not easily, if you are not established call, how frustrated you will be. You know, that's the kind of things we require, human beings nowadays. But the technology everywhere, it may not be, it has maybe also other side of it. Okay, so that's the requirement. This thing, that means, you know, the coming generation will be ruled by the battery, the wind, solar. Even people try to manufacture a car outside with solar panels. That is also may be coming. Okay, the solar panel is going to charge your battery, and that's how through you can run your car. Of course, this is the three things which is going to rule our what you call the world and life, everything, because we will be more and more depend upon this, but that depends upon the performance, depends upon the materials. Okay, and that's where the things are right now the costlier. Okay, so lithium ion is much costlier than your lead acid battery, but it has improved performance. Okay, And another two conventional things which is going to come in a big scale is the fuel cell which runs on hydrogen. Hydrogen is freely available, but the technology problem exists. Still those stacks which is used in fuel cell is imported. Why fuel cell is so much costlier is because nobody is manufacturing a fuel cell in India. The stacks and other thing, it has to come from China. Okay. So whatever you do, whether you brand or anything, it is originated from them. Okay. So that is another kind of technology which has a large potential. Of course, people are thinking going to use this hydrogen, but hydrogen has its own issues. Okay. So this is another kind of a material which has a very important role in what you call your the applications, coming generations. Okay. If you store hydrogen or if you use hydrogen which is available in water, okay, you can electrolyze and other things, but the technology is costlier. Yeah. In NITK we have one stack of 1 kilowatt fuel cell. Of course, some universities, IITs have setting up a research center on the fuel cell. But you know, last time in IISc there was some blast. The students were not much work on this because hydrogen is dangerous. But it can be easily, you can get, not like the petroleum product and other things. Okay. But if you use it properly, there may not be such incident will happen. Yeah, that is a great thing. You get a fuel by splitting water. Okay. But the technology, yeah. Another kind of source which is going to come, the kind of things which is used in aeroplane and other thing, but it is similar to a gas turbine and kind of things. Okay. There also you require magnetic materials. Okay. Of course, I will end my talk because you know the future is going to run by wind, depends upon wind, solar, batteries. All this, the current is the bottleneck in terms of materials. Okay. Until unless you improve the material performance, whatever you do, other technology, which will not going to help. Okay. Like the solar cell still has a efficiency low, so you require large area to build up your plant. Okay. Of course, it may be cheaper, but the efficiency required to be improved. Okay. Then wind, it requires a permanent magnet materials. Okay. So you have to have better materials there. Okay. And then you talk about batteries. You require a better material which has a better property compared to the kind of things. And most of this now depends upon lithium ion. Okay. So that is why these three things will going to rule the world coming the generations. Okay. So there is a lot of from you people, that lot of things required to be done. Okay. So you will going to do a lot of, maybe interested to, or you may end up in doing some research where this kind of materials becomes very important. Okay. I do not know how many of you are from various institute or something. I see many of you are the students of this college or somebody somewhere else, or they may be the faculty members. Okay. So you can take into account, but doing research in material level is very difficult because we may not have that kind of facilities in every part of the country. Okay. But that is where the future lies. Okay. If you get these materials, okay, your things goes down. The cost, everything goes down. Okay. So that is why this conference, whatever they are organized, is on a very important theme. Okay. Where the computer, communication, all these things has done up enough in this thing, where now we are in the stage where we depend upon material to deliver higher, better performance. Okay. Only once you have better material, then only you can improve those other part of it. Okay. So thank you once again to the organizers of this conference, as well as Thanga Prakash, for inviting me to this to share some of my things, because even though I am not an expert on materials, okay, but I works on renewables. Okay. So that's where, thank you also Dr. Mani to give me a lot of inputs on material. Okay. Thank you. I am there. If you have any questions, you can ask, or you can, otherwise you can contact by email. Okay. Yeah.
Yes.
Yeah. 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 Yeah.
Biodynamic and isotope.
Yeah.
They generally use their magnetic property at about 80 degrees, 60 to 80 degrees. It starts deteriorating. So these PMGs are basically not useful in our country because sunlight is plentifully available either in Rajasthan or in Ladakh. Ladakh temperature can go below minus 40 degrees centigrade, and in Rajasthan it can go very well above 55 degrees centigrade. So don't you think that we should think in a different paradigm? We should, invest in different paradigm of research rather than following countries like China, wherein the country is very cold over there. It has a moderate temperature. Like to give a best example, recently we purchased a lot of PPE kits from China. They did not fare well in India because we had to discard 60% of the PPE kits because they were the artificial blood test penetration was failing because of the higher temperature. India is a tropical country. So what is your opinion about that?
Good. What he said is very important question, that why we should depend upon somebody else's material because our region may not be suitable to use those kind of things. Of course, that is exactly true. India has wasted its energy, otherwise it would have been the world leader in the solar. Compared to cold countries, okay, where they may not get a sunshine many times, okay, we could have been the world leader in the solar because you see the geographical condition of the India, okay, the solar. So in terms of deploying in Indian context, the solar is a better option rather than the many other kind of things, okay. Yeah.
Concentrated photovoltaics.
Yeah.
Mixing photovoltaic concept and thermal.
Yeah.
Solar thermal, concentrated photovoltaics. Yes.
Yeah.
That's a secret. Not secret. It's a policy paper is there. Get in that condition, get only 15% from thermal. Try to get 85% from photovoltaic. When sun is there in Rajasthan, get 85% from concentrated sun energy using parabolic mirrors. It is an evaluate technology. I read in one article.
Yeah, that's a good thing. India has in Noida.
CPV, concentrated photovoltaic technology, where thermal energy is 80%, 20% only cells.
Yeah.
But such high heat cells would melt.
Yeah.
You have to cool it. But
Yeah.
I don't know beyond that.
Yeah. What he was telling is the technologies, the which is getting advanced there. Okay, that is what using the solar kind of things, both thermal as well as the normal this solar plants, mixing them. Yeah. 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 No, that's the kind of different manufacturing of the solar panel. Okay. So that is going to come. Of course, as he said, it's better would have been a concentrated. The time is not over. We can still concentrate on that. But the material technology also plays a very important role in most of your applications. Okay. So one thing we can concentrate more on solar, this one also, okay, and also based on the region, what is suitable for that region, we can utilize and power our requirements. Okay, so that is how we can operate to avoid dependency on somebody else technology or the somebody else material. Okay, so thank you for raising the important question. Okay, so that's where we can think of. Okay, of course the government is also thinking, that's why solar is coming more. Yeah. Yeah. Okay, any other questions? Otherwise, yeah, you can email me also. Okay, so thanks for your patience here.
No organization.
Narayan Gaonkar for his inputs on renewable energy. And as a token of love from the AJI family, a memento for you.
One panel sessions will be held here and one more at Seminar Hall 2. Students can leave and the participants please stay back.